Hello everybody, welcome back to yet another Classic Arcade Repair. I have a new job starting today and I have this note that came with it. 4 3-stack boards plus 1 2-stack board. These are Space Invaders. 4 power supplies in various states of disrepair. No image except white screen only, and game does not play blind. Dead, in other words. It says I have retained 1 working power supply with proper voltages and reset, and still nothing happens. Board is dead. Would love to have you film this to learn. Thanks, Ken. Well, Ken, we are going to record all of this for you. Okay, so we got 4 3-stack Space Invader boards and 1 2-stack. How's about we dig out and we find the 2-stack first? You know what? Scratch that. 4 power supplies in various states of disrepair. Let's go through all 4 power supplies first. Okay, so these are the 4 power supplies. These are Taito Space Invaders power supplies. So we'll have to get them out of these cages and start taking a look and see what we have going on here. These are 100 volt supplies. You can see AC 100 volt. And I just so happen to have a 100 volt outlet. So I'll just make a plug on one end that'll plug into here, and then the other will be it'll plug into there. So I'm sure I have cords that I've cut off of various things. I've got cords around, so I'll just make one for this. And yeah, so we'll go through these one at a time. And this is just a line filter, so I'm just going to bypass this on all of them. And yeah, so all right. And the thing is I'm going to have to just have wires with things to plug over these, because I don't have that connector. So I'll have to get the pin out of this. I think I have I don't know if I do or not have the power supply manual for these. Anyway, that's something to look into. I know I had it at one time. I don't know. I'll have to check that out. Anyway, all right. Let me start with one, and we'll start with the one that does not have that on it. We'll start with this one, and it says Space Invaders trim line power supply. And Joe over at Joe's Classic Video Games would appreciate this. What's wrong with it? It's broke. Okay, just getting this thing out and starting to look it over. First thing I did was look at the fuses, and this one is blown right here. The rest of them are good. This one's blown, and it is the +5 fuse. You can see +5 down there, right there. +5. -5, the 12 volt fuses, and that's going to be your probably fusing the hot coming in AC. So our 5 volt line is dead, blowing the fuse. So I really need the schematic for this to find out to track the 5 volt circuit, right? Yeah, pretty crazy power supply. Yeah, that's really what I need to do, is try to find. I'm sure that should be able to find it, right? Alright, that's the first thing I'm going to do, is look for there's a bridge. Yeah, there's so much going on this thing. I really need a schematic. Right now, it's just a jumbled gobbledygook mess. So, all right, yeah, let me look into that. Is it a burn mark? I don't know. I'll put my meter on that diode right there, and that's a burn mark, isn't it? Was that replaced? That diode replaced. That diode was replaced. Okay, interesting. It's a clue. A clue. Okay, yep. Find a schematic. Okay, well, I contacted the owner of all of this, Ken, and he sent me this. This is the schematic for this power supply. I printed off a few copies of it, and I'm actually going to upload this to my Patreon page under schematics and manuals. So that'll be added to that. And so if you're watching this video and you see this and you want this, that's where you can find it. So yeah, I'm just kind of looking over this. I need my glasses, so I'm going to go get my glasses before I really dive into this. I kind of preliminarily just matched things up. You have the transformers T3. We have T3 right there, and T3 is this guy. This is T1, which is this guy. And then we have T4 here. T4 is this little guy right here. Oh, I can't see. Can't see, guys. It's one of these. One of these little ones right here. Those little red squares, those are transformers. That's this guy right here, T4, and this guy right here, 2 and 4, are those two little ones. The two little red ones. These caps, these 6 capacitors right here, are all in parallel right here. These 6 caps, those can all be replaced with one cap. Okay, that's these guys. I would imagine these 4, that's C7, C10, 7, 8, 9, and 10 maybe. Yeah, there's 7, 8. That can those two can be replaced with one cap, and then these two can be replaced with one cap. So, you know, these two, whichever those pairs are, can be replaced with one capacitor. And we have here these double diode things, whatever. These are these little ICs on the heatsink, D6, D7, little weird little double diode things. D15. I think there's only the 3 of them. It's these things right here. That's D7. D6 is right there, same thing. D15 is right here, I believe, one of these. So the bottom line is, with this schematic, I should have no problem repairing this supply. This is the 5-volt circuit right here. And how this works, I've kind of been looking it over a little bit. And the 5 and the negative 5 volts look like it's a 10-volt range straddling this reference. Is kind of what it looks like to me. Because this reference comes down, and it's the it's reference from this transformer T1. It's shared, it comes down right here, and is right here, and it goes to this, and it's probably connected here too. So that is all connected, and then you have this circuit here, and I think this just makes a 10-volt range, and the reference is right in the middle of it. That's kind of the way I'm looking at this power supply. And that gives you 5 and -5 with the middle being 0 volts. So you have a couple biasing elements right here, IC1, IC2. These are biasing the transistors that drive these little red transformers. The other one biases this guy right here, and these drive these transformers, which is part of each individual circuit. This is the 12 volt circuit up here, and then this is the 5 -5 circuit here. That's these two guys. They're the same part, same type of part. This is the 555 that runs the reset right here. Okay, and this tilt is just part of this transformer. It's part of T3. T3's right here, this guy. Yeah, so C3 is a big capacitor right there. C3, I would imagine that probably filters line in, C3. This is main line in, is this guy right here. This bridge. That is C3 right there. That's filtering. That's the main filter on the incoming full wave rectified AC. Okay. And it looks like we got a couple. These are probably like pass resistors, you know, current sensing resistors or something like that. 0.47 ohm. Two of them. 0.47 ohm. What are they? Are what? R1 and R2. R1 and R2. I would imagine those are There's R4. I'm having a hard time just seeing. I can't. It's probably in the 5 volt circuit, I would imagine. Oh, I don't know. R1 and R2. Oh, right there they are. R1 and R2. That's just for the incoming AC. Before it's rectified, before it gets to the rectifier, it goes through. You know, each side goes through here, just to kind of limit the current coming into the bridge. We have an inductor here with no value. That is probably this inductor right here. Coil. They didn't put no value to it. Oh wait, there it says L1. So there is no there's no value, and that is definitely this guy. Big inductor. So anyway, pretty cool. We have some diodes that are just used for suppression here. This big Zener diode. I would imagine that's a Zener diode though, I think. That's probably used as actually some kind of a regulator for biasing this transistor right here. Yeah, that's got to be what that's doing. This Zener diode is probably just regulating. It's for bias regulation, because it's driving that transistor, the base to that transistor. Probably the same circuit down here. Yeah, there's your Zener diode regulating, driving the base to this transistor, which is doing something with this primary. I don't know. I don't quite. It's opening. It looks like it's turning this on to allow the current to flow through the whole transistor. So I would imagine if this turns off it will in turn turn off the transistor, and no current will flow through the transformer. I guess that's kind of the way that looks. Cool. So we have a blown 5 amp fuse. Okay. So you know what I kind of want to do? I think I have a circuit breaker type thing, maybe. I don't know. I'll have to look. I'd like to put a fuse in here and sacrifice a fuse just to see if this indeed blows fuses. You know what I mean? So I think that's what I'll do. I'll sacrifice one fuse, check this thing out, and because if this just isn't working and it's not driving this, and this is being turned off and not, would that blow the fuse? I don't think so. I think we have a short somewhere, right? We have an overcurrent situation someplace. It's blowing the 5. It's blowing F4. No, F5. It's blowing F5. Right there. This is the fuse that's being blown. So yeah. Well, I would imagine it's after the transformer then. Interesting. My initial thought, and this could be completely wrong, I don't know, but it's just trial and error, just thinking out loud. I think that the fault would have to be after the transformer, because if it was before the transformer, it would blow the fuse coming in, right? And if this is open and this is not conducting and there's no current coming through here, then there'd be no current over here on the transformer. So it kind of tells me that it's got to be on this side of the transformer in the 5-volt circuit. That's the approach that I will take. But first things first, I want to pop a new fuse in here and see if it's just a funky fuse, because you never know. So, all right. Okay, so I found myself a cord that I just had, and I put a connector on it. And I looked at the back of this, and you can see here that it's the 2 outside pins. And this is the one that's fused, so that's going to be the hot side. You always fuse the hot side. So I took my meter and I put a little black dot by the hot. And if I just take this and pop this in here, and take the other end, if I can get it, and the flat blade, the one that's not big, is the hot. That's this one. This one right here with the bigger end, that's the neutral. That's the hot. Well, that's how you want to do that. Okay, so this will plug right into my 100-volt outlet, because it needs 100 volts AC. And I'll put a new 6 amp fuse in here and we'll watch it burn. Okay, I don't have any 6 amp fuses, but I got plenty of 7s. And if this has a short on it, 6 or 7 ain't going to matter. It's going to burn like it's turned off. Light is not on. I've got it plugged in, see? I've got it plugged in up there. And it's not turned on. You know what? I'm weird about that, so I'm just going to unplug it like that. And we'll pop it in here. And now I'll plug it in. And when I turn it on, we'll watch that smoke. I'm going to turn it on and let you watch it smoke. Ready? Okay, focus, focus, focus. I can't really tell if it's focused. 1, 2, 3. It did not smoke. Hold on, let me turn it off. I got the monitor plugged in. I got my Nintendo monitor plugged in as well. I don't want that coming on. So I'm going to turn it back on again. It's on. And it's not smoking. I pulled the pin out for this plug here, so I'm going to go grab that. And I'm going to have to put a load on this thing and everything, but yeah, it's not smoking, so interesting. Let me go ahead and turn it off, unplug it, and let me go get that pin out. Okay, I've got the pin out there, and you can see there's 6 grounds right there. Those are the 6 grounds. So I've just kind of got my ground lead kind of just wedged in there a little bit. And we've got 4 5-volt lugs right there and there, you know, those 4. Then you got -5, -12, so those negatives are up top, and then you got 2 12s. So, and of course, it's not loaded, but I want to check the voltages, and I can actually check the 5 volts and the -5 right at the fuse. So, yeah, let's do that. Let's turn it on and see what happens. Okay, it's on. -5 1, 581. Unloaded, that's pretty good. -12, +12. Goodness gracious, is it just a fuse? It's just a fuse. And reset is this one up here. And that's 5 volts. So it's an 8080, which is, I think an 8080 is supposed to be a low. Master clear. You know what? That might go onto the board and then get... I think it does. I think it goes to the circuit board and then it gets inverted on board. So I think that's correct. So this thing seems to be working. I'll have to load it and then see what it does loaded. But it looks like it was just a fuse. And yeah, if that's a 7 amp fuse, that's not going to matter. Yeah, you probably want to put a 6 amp in there. That's what it's rated for. But if this thing has a short on it and it's killing fuses, that 7 amp fuse isn't going to matter. It's going to kill that fuse too. So I could put a 5 amp fuse in it and it would work fine. But we need to load it and see what happens. Does our 5 volts stay? Because you know how sometimes that happens to where you load it down and then the 5 volts just disappears. So this doesn't have any kind of regulating IC like an LM or UA723. And those things are infamous for going bad, and then you'll have 5 volts unloaded and then you load it and it goes down to 1 volt. Now, these guys here, these little amps that are driving the transistors, that drive these 2 little transformers that look like kind of a stop type deal. They look like an on-off circuit almost, because if these aren't working, it's going to turn this transistor off right here, and no current's going to flow through the transformer. So if these things aren't up to snuff and aren't doing what they're supposed to do, which I think they would be, because it wouldn't even do anything. We wouldn't be getting any 5 volts. You can't have voltage without current. And you can't have current without voltage. You know, just kind of go hand in hand. You know, you kind of can, but you kind of can't. Where there's one, there's usually the other, right? So, yeah. See, if like if this right now, it's not really having a current draw. So you can have 5 volts and it's got probably a minuscule amount of current going through it right now. So if you load it and it dies down, that just means it can't provide the current, and you can't have voltage without current. And you can't push current without voltage, right? So that's what we're going to look for. I got to load it down and see if it works. Okay, are we ready to see what happens? I've got 1 amp or 1 ohm, so it's a 5 amp load on this thing, and we'll see if our fuse blows out or what happens. I got this thing ready to go. It's all hooked up. Okay, here goes nothing. We're watching our fuse. Okay. So far so good. 5.27. 5 amp load. Plus 5. That ain't going to do nothing. Screwdriver, please. Plus 5. There you go. Plus 5 with a 5 amp load. Guys, it was just a fuse. It was only a fuse. Yeah, getting warm. Getting a little warm. Okay. Loaded down with 5 amps. We're good. No problem. Funky fuse? I don't know. Yeah, I do recall that the reset signal does get inverted on board for the 8080 processor. That I do know. So we're good. This one works. All right. Well, I got a handful of minutes worth of content here. I think I'll just upload this as it's only a fuse repair. And remember, we do have 3 more of these things sitting over here, so this will whet your appetite. I have 3 more of these power supplies and 3, I believe, 3 board sets. Maybe 4 board sets. I know a few of them, 2 or 3 of them are 3 stack, and there's a 2 stack, or maybe something like that. So there's quite a bit to do here. But yeah, this one's holding nice, and you know what? I need to put load on the 12 and the negative 12 as well, and that's what this is for right here. So I'll load that down and check that next. All right, before that I switched it over to negative 5, and we'll check the negative 5. Uh-oh. Turn it off. No negative 5. Ground. Negative 5. Hold on, I'm going to check the fuse and I'll be right back. Well, you can see here, this fuse is rated at 1 amp. And I've got 5 amps on it. So of course that's going to pop that fuse. I need to use this one right here. This will put about, well, I don't know. What is this? I think this is like 50 ohms or something like that. So, well, current VIR, so current is voltage over resistance. Voltage 5 divided by 50. I don't want to work my brain that hard. 5 divided by 50. .1 amp. That's perfect. So we'll go ahead and hook this up to it, and that'll give us, I got to replace the fuse, and that'll give us 0.1 amp-ish. So let's do that. Okay, I have this one hooked up to the negative 5, and I put a 1.5 amp fuse in there because I don't have 1 amp fuses. So, alright, let's fire it up. And here we go. Move that. Oh, I'm not on the right spot. I was like, why is it not working? Well, because I'm not on it. That's this one. Yep, I got to turn it up. Let me turn it off and do this properly. I don't want to be shorting anything out. Go ahead and put that just like that. That's your ground. And then for -5, I can just touch the fuse. Okay, so let's turn it back on. There we go. Touch the fuse. -5.01, perfect. And it's loaded. So now I can use this same thing right here and put it on the 12 volt lines, and it'll be about a 1/2 of an amp. So let's go ahead and turn it off. And this is -12 right here, and I'll be able to just touch the fuse. So let's go ahead and fire it up. Okay, -12, good enough. And let's turn it off, and let's go over to +12, and it's these two right here on the end. Turn it on, and touch the fuse for 12 volts. So that is this power supply fully loaded. I can turn it off, and I can actually hook the 5 volts back up. These are, I have to build these little adapters. This is just straight up amp male to amp female to plug into that. I just make these little adapters here so that I can hook them up. And I have that's my power supply testing bag right there. So I'm going to go ahead, hook up the 5 volts, and we'll have everything except for the -5 hooked up, because I'm going to leave the 12 volt hooked up. Okay, I hooked the 5 back up. Go ahead and turn it on. And we've got the 12 volt loaded. There's the 12 volts. We've got 5 volts loaded now, which is right here. And 561. 5.5. You know what? I should test it at the load. 5.2. Let's turn that down just a touch. And obviously affects the circuit a little bit with other things loaded. So right now I'm loading 12 volts and 5 volts. So we have 5 volts loaded. So that's good. And negative 12 is not loaded, so it's a little high. And negative 5 is not loaded. So that's it. This power supply is good. So I'm going to go ahead and upload this. We got more of this to come. I'm going to have 3 of those guys. Hopefully some of these are bad, right? I'll go around the back of this thing, just check solders, make sure everything's, everything's soldered good that needs to be soldered good. But yeah, this thing's fine. This thing is A-OK. 5 volts. All right, guys. Stay tuned for more power supply and Space Invaders PCB goodness. Bye for now.